Hello, grade 5. This is the PowerPoint lesson for circuits. So in this PowerPoint, we have important questions and also vocabulary for you to study for the checkpoint in October. So remember, our question for this unit was, and our investigation was, how do you make the light bulb come on? So at each table, each group had some materials, some parts, and you all were able to turn on the light bulb. So you made predictions, you predicted how to turn on the light bulb, and then after we turned on the light bulb, we talked about the parts we needed to make a light bulb turn on. So we had the conversation about that you needed something called a battery, and so we weren't sure if it was one battery or more than one. Other people said you also needed to have wires, so the question of one or more than one also came up. A cell holder. We weren't sure at that point if we needed a cell holder or if it just made it easier to connect. Everybody agreed that we needed a light bulb that worked, not broken. We weren't sure if we needed the red button on the black thing, which was the cell holder. And then we weren't sure if we needed the light bulb holder. But as we did more investigations, we realized the parts that we must need to turn the light bulb on. So this was from the other class here. They also added that everything must be connected, but is there a way to connect them? Or do they simply just need to be touching? The parts need to be touching each other. How do we connect them? So that was a question. Because just because they're connected doesn't mean the light bulb will turn on. So we had to make sure that, yes, true, we connected them, but they must be connected in a certain way. So we kept asking the question. We did more investigations with circuits, and we continued to ask, how do you make the light bulb come on? We talked about the components or the parts that we needed. So first we tried with 2 cells, 2 wires, 1 light bulb, and a cell holder. We also had a light bulb holder, and we were successful. But do you need all of those parts to make it turn on? So we drew a diagram. First we drew a picture of the circuit that you see here with 2 cells, 2 wires, and a light bulb. At first, some of us didn't know the names of these parts, so we just called them thing and their color. So black thing, red thing, blue thing, orange thing, and everyone knew the name of the light bulb. So after we drew the circuit picture, we learned about the circuit symbols. Okay, so these symbols represent actual things, and they don't always look like those things. I know when we drew pictures, we tried to make the pictures look like, for example, the bulb, but if you look at the symbol, the X with a circle, does not look like a bulb, but that is because it's the symbol. So we learned the symbol of the cell and then 2 cells together. We learned that you can call that a battery or a battery. Wire is just a straight line. We learned about closed switch and open switch symbols to show when our circuit has that. So next we drew, using the symbols that we learned, we drew a diagram of the circuit with 2 wires, 2 cells, and 1 light bulb. Okay, so this slide here shows us the difference between a circuit picture and a circuit diagram. So the diagram has the symbols, the circuit picture, the parts in the circuit picture look like more like the actual parts for a real circuit. So this circuit diagram does show a closed switch, a bulb, 1 cell. Okay, the long line, skinny line is positive and or plus, and the short line but fat line shows negative. Okay, that's the minus symbol above it. So we continue to think about how do you make the light bulb come on, and people made claims. I remember when we made our predictions, some people said you must have a red wire and a blue wire to make it turn on. You must put the red wire in the red hole and the blue wire in the blue hole. Other people said you have to put the if you use 2 cells, you have to put the negative, something they called negative part of 1 cell against the positive part of another cell. Other people said you must use a cell holder or you can't turn on the light bulb. Some people said you must have 2 cells to turn on the light bulb. Some people disagreed and said you must have at least 1 cell and a wire to turn on the light bulb. And then some people said something called electricity. It turns on the light bulb and it comes from the wire or conductor. So which of those claims or predictions are true, which are false, and if they are false, why are they false? So here are the answers. So look at the first claim about red wire and blue wire. That is false. So why is it false? Because the color of the plastic covering the wire is not a factor, it's just a color. So the wire could have been purple or green, it doesn't matter. The factor that affects the outcome of the light bulb is the copper metal inside the plastic. That is the factor, because the metal is a conductor and that's what allows electricity to pass through. The negative part of 1 cell against the positive part, that claim is true. The next one, you must use a cell holder. That's not true. Cell holder makes it easier to hold the cells together when you put the circuit, but you don't need one to turn on a light bulb. You can put and hold each end of the wire against each end of the cell with your hands. Next, you must have 2 cells to turn on the light bulb. Not true. False. You only need 1 cell. We learned that by doing the investigations, by multiple tests. Next, you must have at least 1 cell and a conductor like a wire to turn on the light bulb. That's true. And last, electricity to turn on the light bulb comes from the wire or conductor. That's false. Electricity comes from the cell. The electricity from the cell flows through the wire to the light bulb. How do you put the cells in the black thing to make the light bulb turn on? A, plus and plus together, B, minus and minus together, or C, plus and minus together. If you said letter C, plus and minus, or positive and negative together, you are right. So then these slides are just showing some of the tests we did using different parts and different number of parts. So this is 2 cells, cell holder, 3 wires, something called a crocodile clip. That's the black part next to the wires, and a bulb. So here's a different test. using a switch this time. We added a switch, and then remember we drew a diagram of a circuit with an open switch and closed switch. We learned that open switch means the light bulb is off, and closed switch can turn on the light bulb. So this time we have 4 wires. This time we have 4 cells. So think about how we didn't do this test in class, but think about how you would draw the diagram with 4 cells. So let's go back and think about the main question again. Do we need these parts to turn on the light bulb? Do we need 3 wires to turn on the light bulb? Do we need a switch? Do we need a cell holder? Do we need a crocodile clip? So this is the test we did. Some people claim that we only needed 1 wire and 1 cell to turn on the light bulb. So we did this test and we realized that's true. So we talked about it again. What parts do we need to turn on the light bulb? And some of you said a light bulb, at least 1 cell, and at least 1 wire. But we also need to remember that these 3 parts, we must connect everything, not on the plastic, but on the metal or other material. So it says all metal. And then we have the question about, does the energy to turn on the light bulb come from the battery or energy from the wire? So we concluded, this is the final conclusion, what parts do you need to make a light bulb turn on? We need 1 wire or conductor. Conductor is any material that allows electricity to pass through. We need a cell, so a source of energy or electricity, a light bulb, and we must connect these parts at their metal points. And finally, of course, we need electricity, which comes from the battery and flows through the conductor or wire to the light bulb. So a circuit is what we build with the parts. It's a closed path in which an electric current flows or may flow. So notice the word flow, that's an action. That's like water moving. So electric current can move like water through a wire or a conductor. So this slide shows you the difference between a closed circuit and open circuit. We built both. So when the circuit's closed, the electric current flows. You can remember closed and flows, almost rhyme as a memory trick, flows around. And when the circuit's open, the switch is off, electric current can't go around because there's a break in the circuit. So look at the green highlighted word that says a break. That's an open circuit. And this is a picture of a complete circuit or a closed circuit versus an open circuit. So notice the wire is broken. There's a break in the wire on the picture on the right side. You can see the opening or break. Which material and object allows electricity to go through it? A, plastic spoon, B, metal scissors, or C, wooden spoon? If you said B, metal scissors, you are correct. So we didn't do this table, but if we had done it, I want you to think about this question. What objects materials can help make the light bulb light up. So we have wood chopstick, plastic chopstick, steel chopstick, plastic straw, rubber balloon, and aluminum foil. So aluminum and steel are both kinds of metal. So these are the answers for our question. So any material or object that resulted in no is what we call an insulator. Any material and object that resulted in yes is what we call a conductor. So you can use these sentences when you study to explain a conductor and insulator. So you can say, steel is a conductor because it allows electricity to pass through it. Plastic is an insulator because it does not allow electricity to pass through it. So again, as mentioned in the other vocabulary PowerPoints that I put on YouTube, when you study, make sure you read and read out loud. So we could have drawn a diagram or a picture of one material that made the light bulb light up and one item that did not. So what is a conductor? A conductor is a material that allows electricity to pass through it. So just like the copper wire inside that allows electricity from the cell to flow through it. Now the plastic around the wire is what we call an insulator. So when we touch it, we don't feel the electricity passing through. And an insulator is a material that does not allow electricity to pass through it. So it blocks the electricity. Electricity cannot pass. What is electricity? A basic definition is a flow of charged particles. So here, if we had had time to write our circuit's conclusion, these are the words that you need to know and use to conclude about how to make a light bulb come on. In grade 3, we answered this question: how could we make a wire using aluminum foil and a plastic straw? So in grade 3, the kids discovered that they could roll the aluminum foil to make a thin wire, like a skinny wire, and then stick it inside the plastic straw. Because the plastic straw was like the plastic insulation, and the aluminum foil, because it's a metal, is like the copper wire. Our next investigation was, how do you make the light bulb shine brighter? And we made a prediction. We wanted to figure out the factors that not only turn on the light bulb, but make it brighter. So our first investigation was 2 red wires versus 8 red wires. So we asked, does the length of the wire affect the amount of light the bulb puts out? Our second investigation was, does the number, or I should say, yes, does the number of cells affect the amount of light the bulb puts out? We had 2 cells versus 4 cells. And then the third investigation, does the number of light bulbs affect the amount of light? 1 bulb versus 2 bulbs. So we made observations and we realized that to make the light brighter, we needed a shorter wire. More cells also makes the light brighter, and less light bulbs. To make the light dimmer, which means less bright or darker, we need a longer wire, less cells, and more light bulbs. So if we're writing a conclusion about how to make a light bulb brighter, these are the words that we would use. Circuit, less bulbs, more cells, less cells, shorter wire, longer wire, electricity, flow, brighter, and dimmer. And these slides are extra slides. And I hope that helped.